or
Sure.
right away.
Let me know when to
Okay,
start.
so we are now live. You can
Okay.
also check in your mobile.
Sure. Hello everyone. Myself Anwar Gupta. I am currently working at OPE since the last 2.5 years as an MTS 2. Um, I am a 2021 graduate from IIT Allahabad. So today I'll be going through a couple of questions similar to those which have come in the TCS digital exam. Apart from that, uh, let's go through a couple of important segments with respect to the
Guys, if
course.
please let us know if sir is visible and audible to everyone. So please let us know in the
Yeah,
comment
yeah.
section. Yeah.
Let me know if I am visible to everyone.
So if sir is visible and audible to everyone, so you can probably put the
A
questions.
thumbs up or anything. Yeah.
Yeah. So please let us know if sir is audible and visible, so that he can start. Okay. So you can see the comments, Anubhav. So in the comments, it will be
Yeah.
they will. Okay. So
Yeah. Thank you very much. Let me know if I'm audible, if the voice is perfect, the screen is perfect, if you're able to see the screen and everything. Okay. Thank you. Now, first of all, let's. I would need to share with you some particular information about our community, and basically, in our particular community, we have launched several courses, crash courses on the TCS NQT 2024 new pattern. We provide live classes. There are recorded contents, various questions, and everything in order to help you crack the examination. This is a a very important course if you're having that particular goal in mind, and comes at a very tempting price of 999. Apart from that, in our community, if you would like to see what all happens in that particular course, we can see with those particular live queries, how the teachers are pretty qualified. Then apart from that, the live questions and the recorded lectures are provided each and every point. There is a lifetime. We provided for lifetime this particular course. And apart from that, uh, in this one, if you would like, there are several significant results that have come by from the people that have joined through this course. As you can see, apart from that, there are timelines and everything provided over this community as well. So if you would like, you can subscribe to this particular channel in order so that you don't miss on anything. There are timetables as well. So that was with respect to this. Now, not taking much of your time, starting with respect to the questions that I am about to solve in this particular video. So, these are some sort of similar questions that have come or would are likely to come in the TCS NQT exam. So, the first one, as we can see here, is richest customer wealth. Let's first read about it. We are given an m cross n integer grid accounts, where accounts at ij is the amount of money the ith customer has in the jth bank, and we need to return the wealth that the richest customer has. A customer's wealth is the amount of money that they have in all their bank accounts. The richest customer is the customer that has the maximum wealth. So, as we can see, we have been given an m cross n matrix called accounts, and in this one, every particular you can say row, that particular row corresponds to one particular customer. The number of accounts that particular customer has lie in that particular row, and these all the elements within that particular row, these represent the wealth of that particular customer in that particular account. Like customer 1 has wealth 1 units in account 1. Similarly, customer 1 has wealth 2 units in account 2, and in account 3, that particular customer has wealth equals to 3 units. Similarly, customer 2 has wealth equals to 3 units in account 1. Wealth equals 2 units in account 2 and wealth equals 1 unit in account 3. Now we need to provide the wealth that the richest customer has. As the question demands, that the wealth is the amount of money that they have in all of their bank accounts. That means the summation of all their wealth in each individual account. So as we can see, the first customer has wealth in the first bank account, in the second bank account, and in the third bank account. So the sum becomes 6. Similarly, for the second customer, the wealth is in the first bank account, in the second bank account, and then in the third bank account. That too is 6. So because in this particular example scenario, the wealth is same. So we need to return the maximum wealth. So that becomes 6 in this case. Let's take the other example. In here, we have 2 bank accounts for each customer, and there are 3 customers. So for the first customer, as we can see in the first bank account, we have 1 units of wealth, and in the second bank account we have 5 units of wealth. Similarly, applying the scenario for other customers as well. So the first customer's total wealth is 1 plus 5, 6. Second customer's total wealth is 7 plus 3, 10. And third customer's total wealth is 3 plus 5, 8. So as we can see, the maximum wealth is 10 of the second customer. So the second customer is the richest and with a wealth of 10. So we have returned 10. So yeah, this is the question that demands. So as of now, what the generic brute force approach that I see here is, for we go through every particular customer and find its wealth in all of the bank accounts. We find the sum, and once we find the sum, we will maximize our answer with respect to the sum of that particular customer's wealth, and that we will maximize our answer with respect to that, and at the end our answer would contain the maximum wealth for any of the customer. So we would simply return that. Let me share with you what I am talking about. Let's take this example for now. So let's say I am at customer 1. I am looping through all the customers. Let's say I am at customer 1. So I have the bank account is 1, 2, and 3. So initially I'll keep on adding the wealth in all of their bank accounts. So I'll simply do in the first iteration for that particular customer, I'll add 1 to my current sum. Then in the second iteration, I will add 2 to my current sum. And then in the third iteration, I will add 3 to my current sum. So my current sum at this point would become 6 for the first customer. Current sum, or you can say current wealth. 1 plus 2 plus 3. This would become 6. And similarly, for this particular second customer, 3, 2, 1. Applying that particular similar logic, 3 plus 2 plus 1. So our current wealth would again become 6. So in this way, our answer would be returned. In the initial, what we will do is we will have our initial maximum wealth as 0, because of, as we can see in the constraints, any particular account of any particular customer can have at least 1 unit of wealth. So our maximum, just a dummy value in order to take in the initial, we can have it as a 0. Because every customer can have at least 1 bank account, and in each of the bank account there can be at least 1 units of wealth. So maximum wealth, our initial is 0. Then for every particular customer, we will maximize our maximum wealth with the current wealth that we had found. So if the current wealth is greater than our maximum wealth that had been found earlier, we will update our maximum wealth. And finally, when all the customers we have traversed through, our maximum wealth would contain our final answer, and we'll return that. So before writing the code, let me just share with you the time and space complexity of this particular approach. So because we are looping through all of the customers, so there are n customers, and each particular customer is having m bank accounts. So n cross m is the time complexity of this one, and space complexity would become, because we are not using any additional memory or any additional space, the space complexity would remain constant. So this would be the logic. I hope I have made you clear. Let me know if you have any particular questions in the comment section. Any questions so far? Okay, so let me proceed with the code. So as of now, I would be coding the C++ solution, and after that, I'll show you the Java solution as well. As discussed in the logic, I'll simply have my maximum wealth. Then I'll loop through all, before looping through all the customers, I'll simply take the dimensions of the matrix. We don't need that. Okay. These are just that, just the looping variables. N, or you can say accounts.size, and so just this. Now we'll loop through all the bank accounts of that particular customer. So volume equals to 0, means less than amounts at the size volume customers. So here I am not doing anything new. It's only I am traversing through all the accounts for that particular customer present at row. I am doing simply that. Now, as I have discussed previously, that initially, while calculating the wealth of the, because the wealth of that particular customer is the sum of the wealth in their individual bank accounts, so we need to calculate the sum. So simply we need to have a particular current wealth of that particular customer, and simply what we'll do is we'll simply add the wealth in that particular account. So okay, Palak Sharma asked, can we optimize it? I'll take up that question. Sure, I'll take up that question. Just let me just complete that. I'll surely take up that question. So and as I have discussed, I am maximizing it at every particular point, and simply I'll return my max wealth. Okay, so let me first just run it once. Okay, there might be some. So yeah, it's accounts S. Some naming mistakes. Okay, let me just sum it. So as we can see, it's passing now. Let me answer those questions. So I would like to ask Palak, like we need to calculate the wealth of every particular customer. Like how are we planning to do so if we are not like scanning through all the accounts of that particular customer? Like we are required to do so. Like we don't have any other option. If you have any particular suggestions how to basically optimize it, like not having to go through the wealth of that particular customer in every particular bank account, then how we can do so, please do let me know. Because as far as I can see it, current wealth of that particular customer as specified in the question is the sum of all their wealth in all of those accounts. So we need to somehow add it. and in order to add that, we have to go through all their accounts. So that particular complexity would be added up, and we need to do it for all of the customers. So yeah, O of n cross m complexity would go. Okay, yeah. So yeah, thank you very much. So yeah, as I have specified, we cannot optimize it at this point. So yeah, so as we have seen the time and space complexity of this particular approach, so we can proceed to the next question as we have solved it. Any particular questions with respect to this as of now? Do let me know. Okay, moving on to the next question. So shuffle the array. So let's read about the question first. So given the array nums consisting of 2n elements in the form, so x1, x2 till xn, and then y1, y2, and yn, return in the array form. Okay. Just one thing. I am really sorry to really sorry I missed this. So just let me. I need to stop. Just stop it. Just give me a second. So what I missed was, and in this particular solution, I had to provide the Java solution as well. So yeah, just give me 1 second. The approach was similar. It's just that that particular course was in this C++, and currently what I'm sharing is the this C++, sorry, Java code. Just give me a second. Yeah. Okay. Okay, so it's visible. Okay. Okay. So, okay. Now let's run it. And submitting it. So Palak is asking which tech stack I am currently working on. So Palak, you're asking me with respect to my coding perspective or with respect to the development perspective? I just want to understand your question. So this question was over. Let me know, Palak, what you are exactly asking. I'll share with you. Now, let's move on to the next question. Okay, so in the company, Palak, I work as a full stack developer. On the UI side, I'm working on React and Angular, and on the backend side, I work basically on Java Spring Boot. On the database side, I've worked on Oracle. However, in my college time, I have also worked on NoSQL databases like MySQL, and also in the development side, I've worked on MERN stack as well. So I hope I was able to answer your question. Moving on to the next question. So we need to shuffle the array. So given the array consisting of 2n elements, x1 to xn and y1 to yn, we need to return the array in the form x1, then y1, then x2, then y2, and then xn, then yn. Both the segments are of length n, as we can see. And what we need to simply do is we need to keep one element of one segment and then bring the corresponding element of the next segment just after it. So x1, then pick y1, then y1 to be in between here. Then x2 is there. So after x2, we need to there would be like x3, right? Let me just draw it on whiteboard. Sorry guys, just a second. Yeah. Okay. So as discussed, let me share with you. It was x1. Apologies for the bad handwriting, guys. It will be appropriate in a few days. x3, then we have y1, y2, y3. Okay, so let's take 3 for this instance. So now what the question is demanding is we need to shuffle the array and we need to make it like between x1 and x2, like y1 comes in here. Similarly, just after x2, y2 comes. Then just after x3, y3 comes. So this sort of shuffling is what the question is demanding us. So the finalized array would be x1, y1, x2, y2, x3, y3. Yeah. So this would be the final, and of course the remaining elements. I have shown that by ellipsis. So this is what the majorly what the question is asking. Now, as we can see in this particular approach as well, sorry, this particular example as well, 2, 5, 1, 3, 4, 7. So 3 came just after 2. 4 came, this is the second segment of 3, 4, 7. This is the first segment of 2, 5, 1. So from the second segment, 3 came just after 2, 4 came just after 5, and 7 came just after 1. So this would be the finalized array. Seeing one more example, let's take this one. So in this we have 1, 2, 3, 4 and 4, 3, 2, 1. So from the second segment, 4 came just after this 1, 3 came just after this 2, 2 came just after this 3, and 1 came just after this 4. So this was the scenario. Now let's move on to the logic section. Now what we can do here is we are simply required to return the result. Now what one thing that I can see here is, first things first, as we can see in the resultant, you can say the array, there we are also given n, which is the there are 2n elements in this particular array nums, and we are given n here. That is for sure. See this, nums length equals 2n, that is for sure. So what we can do here is, there is a section of length n, of section 1 of length n and a section 2 of length n. There are 2 sections in nums1, and we need to use those only. So what we can do here is, from nums length, we can choose that particular element, and the how we will be able to find the corresponding element which will come just after this. Let me ask my question again. So this 2 was there, right? Now the index of this particular 2 is 0, right? Now this from naked eye we can see that, yeah, this particular 3 needs to come after this 2. But how are we saying that? What we can see here is, between any two you can say corresponding elements, like 4 need to come after 5 and 7 need to come after this 1, this particular gap is fixed, and this gap in this particular example, it's 3. And why is it 3? Because this segment is of length n and this segment is again of length n. So the gap between two corresponding elements, like in this case 5 and in this case 4, this gap would be n. So every time, whenever we are required to find the particular element which needs to come from section 2 and come after the element of section 1, that we will be able to find after adding the index of that particular current element with n. Like in this case, 5 is having an index of 1. So 1 plus 3, that is 4. So 1, 2, 3, 4. We got 4. I hope I was able to explain up till this point, like how are we able to select the element that we will need to move from section 2 to section 1. Any questions up till this point? Any questions? Okay, so yeah, as we have seen, I think I have explained the logic. How are we able to find the element which we are required to place from section 2 just after the element of section 1, and how many times we will do these iterations. We will not do these iterations till the entire length of nums. We will do these iterations only for the first section. Because see, we are moving utilizing the elements of section 2 while traversing the elements of section 1 only. So we are only required to traverse the elements of section 1. That means these x's. We don't need to traverse the elements of section 2, these y's, right? So similarly, I think I was able to explain my logic. Now let me share with you the time complexity, because we are only traversing through the entire array nums. So the time complexity would be O of 2n. And the space complexity would be, because we are not using any additional space, so 1. Now, because we are in O notation, big O notation, we do not include constants, so this would be removed. So our time complexity would become linear and the space complexity would become constant. I hope I was able to explain my logic. Any questions up till this point? Do we need to why second section? Why Karthik is asking why SC is 2n. So Karthik, the length of this nums is 2n. I'm not sure what do you mean by SC. I hope I was able to explain myself. The length of this particular nums array is 2n. It is having 2 sections of length n that we need to shuffle. Time complexity is 2 into n. Okay, yeah, right. Sorry, my bad. Time complexity would be linear only. It won't be 2n, because we are traversing only in the first section. Yeah, it will be n. Great observation, Karthik. Thank you very much for pointing it out. It would be O of n only. We are not traversing until 2n elements. Thank you, Karthik. So now we can start coding it out. So first, let's take the size of this particular nums. Maybe we don't need that. So this particular, so in C++ we resemble an array by a vector. If you would know C++, you must have used the SGL library. So we resembled it using vectors. I'll be sharing the Java code as well, as I have shared previously. So vector, let's call it resultant vector. And the length of this resultant vector would be 2n. Yeah. So now, at every I am taking a particular index for the populating the elements in the resultant vector. So Let me share with you why. So when I am at that particular current, you can say current index, whether it be this x1 or x2 at any index, I need to first push this particular element because this is my element from section 1. This must always be before the element of section 2. So that is why I need to push this particular element first. So I will be pushing this particular element in my resultant array, and after that I will be pushing the corresponding element in section 2 in my same resultant array. Like in this one I have pushed 2 and then I'll be pushing 3. I hope I was able to explain. Okay, so yeah, so now let's proceed with the coding. Now this is my looping variable. Let's say index 0, index is less than this. Now resultant at, so at my first in the very first instance, as I am going to push the element of the first section first, as I have discussed before, I'll simply do nums at index and I'll increment my IND. And why I'll increment my IND? Because this particular IND represents the index of this particular resultant array. So we are incrementing that because we have filled this particular index in the resultant array, or you can say resultant vector. Now I need to follow it up with the corresponding element of the second section. So what I'll do is, because index is incremented, and so my this nums would be, as I have specified, how we will be able to find the element or corresponding element in the second section by adding the index, current index of that current index with n. I have explained this solution like scenario during my logic explanation. Any questions at this point? So Pulkit is asking, space complexity should also be ON. So Pulkit, there are two scenarios in here. So the resultant is resultant vector here is 2n, and yeah, I agree to it. Space complexity is taken as 2n, but there are like in scenarios and in interviews, the space complexity of which we use for populating the output, that is like in some scenarios it is not considered. Like it's a good observation that you observed it. Its space complexity is 2n. You can share with it. However, you can also share that if the space complexity like being utilized towards the output, it is being utilized towards the output. So if it is not considered, then there is no other space complexity. Else it is O of 2 cross n. Yeah, that would be the case. And coming back, so I'll increment my index because this particular index I have also populated. So in this way, this particular first two lines use my first populate my this first the element from the first section, and then these two lines populate my element from the second section, and that too just after that to the corresponding element. And how I found the corresponding element? By adding the gap, that is this n. Because after this n, I'll be able to find my corresponding corresponding element in the second section. I hope I was able to clear myself. Okay, so Karthik is saying explain the logic once again. Okay, Karthik. So see, let's talk about these 6 elements only, right? Let me just erase few things. Okay. Okay, right, Karthik? So let's talk about this 6 elements only. Now, here n equals 3, right? N is 3. Now, okay, let me just erase this. Let's not erase it. Yeah, n equals 3. Now, we, for this particular x, this particular y is my corresponding index, right? This particular x1, this y1 is here. Now, I am simply putting this line so that sections are separated. This is the second section, and this is my first section. Right? Now, see, if we are required to put y1 just after x1, what will you do? Because we need to find out how we can find out the corresponding elements corresponding to this x1. How we will be able to fetch this particular corresponding elements? Even, okay, so because these are the very first elements, let's not talk about these. Let's talk about x2 and y2, so that you can understand better. So after x2, we need to place y2, right? So between x2 and y2, how many elements would be there? Because this is the second element, right? This is the second element. I'm at this point talking in terms of one-based indexing. This is the second element. Now, after this particular, let's say there were n elements. So how many elements after this x2 were remaining from the first section? It would be n minus 2, right? It will be n minus 2, right? And in here, when we have to find out that, yeah, from the first section we are taking the second element, so from the second section also we are required to take the second element. We are required to take the second element. So this was the second element, right? Now before it, how many elements were there? So it will be 2 minus 1. Subtracting this, right? Subtracting this itself, right? So these would be the number of elements before it. So between this x2 and this y2, the total number of elements would become n minus 2. Let me erase this actually only. Just yeah. Yeah. Okay. Between this x2 and this y2, how many total elements would be there? N minus 2 plus 1. These are the total number of elements between these, right? At this point, I am not taking into consideration any specific n value. I am taking this n value as generic between the corresponding elements. So that so what will this become? This becomes n minus 1, right? These are the number of elements between x1 and x2 and y2. So now we need to find y2. How we will be able to find it? We need to this particular index of this particular element needs to add these many number, this number, as well as it needs to add plus 1 in order to reach this element. Because see, n minus 1 elements were here only. So at least the index needs to move this much, and after that it needs to move one step more in order to reach the appropriate corresponding element, right? That is why I say that if we add plus 1 here, because the index needs to move through n minus 1 anyways, and it needs to why this plus 1 is there? In order to reach to the exact element. And in this manner, the total distance that the index would need to move in order to reach the appropriate corresponding element, it becomes n. I hope I was able to explain. Karthik, can you please confirm if I was able to explain? Hello, any response, Karthik? Okay, got it. So now we can move forward. Now simply we need to return the resultant array because everything else was done. So I am simply running it and let's submit it now. So yeah, it's submitted. Let's move on to the next question, guys. I hope there aren't any questions with respect to this. This was a pretty easy one. Yeah. So now we are going towards a pretty medium question. First, read it out. Given an array nums of length n where all integers of nums are in the range 1 to n and each array appears once or twice, return an array of all integers that appears twice. Okay, got that. You must write an algorithm that runs in linear time complexity and uses only constant extra space. Okay, got that. So here in this example, as we can see, 4, 3, 2, 7, 8, 2, 3, 1. So in here, as we can see, the only elements that were appearing twice were 2 and 3. Right? So these were appearing twice, so these came into the answer. Then similarly in this one was appearing twice, so it became here, and in here it was only one single element, so nothing was there. Okay, so now every another thing what we are given, so this was the range in the length of n. Nums at I always lies between 1 to n, and each number appears once or twice. Okay, got that. So now what we have here, we need to find only the element that appeared twice. Okay, got that. So what is the very first approach that hits my mind? The very first approach that hits my mind is we can have you can say a counter variable where we'll count the number of the frequency of each particular elements, right? So 4 would appear 1, 3 would appear 2. Let me write it down here only. Four would appear 1, 3 would appear 2, 2 would appear 2, 7 would appear once, 8 would appear once, 2 and 3 are counted, and 1 would appear 1. So this would be my map, and then I will traverse through my map and will check which all elements are coming twice, and then I'll simply like store them and return them. So this would be my generic approach. I hope everybody was able to understand this particular approach. This is a fairly simple one, and with respect to the time and space complexity, it would be O of, like we would be traversing the numbers array and then through the map once. So it would be n plus, like we would be traversing the map once. So roughly we can say n once again, linear traversal twice. So it would be like that. So it would be 2 cross n. However, because we don't we neglect constants in the like big O notation, so it will be linear time complexity. And because we are using external space like an additional hash map or something, so an additional space complexity would be O of n, where n is the length, of course. So this would be the initial approach that comes to my mind. I hope everybody is clear with respect to this. Okay, so Mohit Bansal has provided another approach as well. So yeah, this he has provided another approach as well, and I was about to share it with you guys. So that approach is we would be sorting the entire array. So when we are sorting the entire array, it can be any order, ascending, descending, it doesn't matter. The equal elements would appear together. So we will be able to every as in the question shares that every element appears once or twice. So we would check if the just adjacent next element is same as the current element. If it is same, then we can add that particular answer to our result and then move our pointer appropriately. That means basically 2 steps ahead, because the next element is definitely the same, right? So that would be the case, and in that way also we would be able to reach to our answer. So let me just write it down here. First approach, in where we used a map. In the second approach, we sorted the array. However, at this point, even if we use the best sorting algorithm, which is merge sort, so the best case time complexity that we can have, even though like I know we would be traversing, that would take a linear time complexity, that is again appropriate. The time complexity that sorting would require, that would become n log n. And one other approach, one more traversal with respect to like finding the actual elements. So this would be the time complexity. In this case, the space, because we are not using any additional space, so our space complexity would become 1. So I hope that was appropriate. So yeah. So Himanshu, in the approach that you are sharing, equal to won't be there in that one, because the question demands the elements which are appearing twice. By equal to, you are saying that it could appear once or twice. So it won't be our answer, and that I have approached in my explained in my first approach. Yeah. So Gunal is having a doubt. Can I use? Okay. So okay, got that. So yeah, this would be the second approach. I think so both the approaches are quite clear with respect to everyone. However, the question demands that if we could solve it in O of n time and constant extra space. Okay, got that. Now let's with respect to the first two solutions, I hope if you would be able to code it. If not, please do let me know. I will share with you the solution of both of these. Anyone require the solution, the code of these solutions? I hope I was able to explain it quite good. Any responses? Okay, so let me do one thing. Just give me a second and I'll share. Okay, let's share it right now only. Let's start with the second approach first. It's quite easy, quicker. So let's first sort the entire array. So in C++, we sort it like this. Now, simply what we need to do is, okay, first have the resultant vector. This is my index. I'll move it appropriately now. Now, what I need to do is, if my current element, that is nums at ind, equals to nums at ind plus 1. If these are same, then what I need to do is simply push the particular number in my answer and we need to move 2 steps ahead this time. 1 step here and 1 step here. because we need to process the next element, because next element is the same only. So it's not required. So we need to move it like this, and simply at the end we'll return a result. Even though this particular question demands a linear time complexity, I am solving this so that for you guys. What's the issue here? Okay, I think the n is not defined. Let's define it. If shuffle array do, okay, so I'm sorry, your name is shown as ACE. In shuffle array, do we need to use 12th line? Doesn't the loop itself automatically increment index plus 1? In the shuffle array. Okay, just a second, ACE, sorry. Just a second. Okay. Okay, so last. Okay, yeah. So you are saying in here why this 12th line is needed. Okay. So you see, the thing is, this IND and this index are different. This index is for traversing through the first section of the array, and this IND is for populating this resultant array. They have no relation with each other. This IND is simply populating the resultant array, and we need to increment it, because once we have populated this value at IND index in the resultant vector, we need to increment it. Otherwise, where the next value will go? Right? And index is for traversing the original array which was given to us, the first section of the original array. Hope I was able to answer your question. See. Any questions, everyone? Okay. So, yes. In this one, it was running and it gave us some particular error. Just give me a second, guys. Let me just check it. Why is it giving the error? Index was 0, index was plus. One second. So index is plus. It is less than n minus 1. Sorted. Okay, sorry. Okay, sorry, guys. I had by mistake written resultant vector there, so it wasn't the case. Now let's submit it and let's see what happens. So this was the second approach. Yeah, as you can see, this has submitted. However, this is not the appropriate approach, because the question demands linear time complexity and constant space complexity. Now, let's move to our most optimal approach. And for the counter approach, I am trusting you guys. You can solve it. It's more simpler than this. Simply use a hash map to count everything and traverse the hash map. If the count is 2, then store that particular element in our resultant vector and then simply return it. So that would be the time and space complexity of that particular approach. Now let's move to our more optimized approach, which is actually having linear time complexity and constant space complexity. So in here, as you can see, each element First, it says that it appears in the range 1 to n. Whether it comes once or whether it comes twice, that is not the question. Every element is in the range of 1 to n, right? Now, also one more important piece of information given here is every number appears once or twice. Okay, so these two pieces are pieces of information are important. Why? Because the approach that I'm trying to tell you, first listen to the approach and then I'll share with you why these points are important. For every particular element, the actual element, if I need to make it, if I need to identify it, because earlier what I was using a map so that I can identify that yeah, this particular number is appearing these number of times. So, but this time I am not. I can't use a map. Otherwise, space complexity would increase. So I need to make this help me to identify that this particular 4 has appeared. Now, how I will do so? I can do something like let me first copy this. I can do something like nums at 0, or you can say 4. Let me just write 4. 4 minus 1. The element at this particular index, that means 4 minus 1. That particular element I'll return. Sorry, I won't return. I'll simply multiply it by minus 1. By minus 1, yeah. So in this manner, okay, element at that particular index is negated to minus 1, right? Now, at any particular point, if while in the second traversal, if my particular ith element is negative, what does that mean? Let me ask again. So in this case, which particular element would be negated? So it would be nums of 3. So 0, 1, 2, 3. So this 7. So this index value would be 3 and nums at 3 would be 7. So 7 would be negated. So in the next traversal, what we'll see is element at index 3 is negative. So there must be some particular element which must have made this element as negative, and so we know that yeah, that particular element existed. So how are we planning to see that which particular element actually existed? So we can say that because this particular IND, how that was found? By the original element minus 1, negating the element at that particular index, right? So if this particular index's actual value is negative, so in that case, my original element which could have been there would be index plus 1, right? Any questions so far? I'm telling you, this is quite an important step with respect to this solution, and this is I'm explaining the crux of this particular solution. Let me know if you have any questions at this point. Please do ask. Okay, moving forward. So, original element was 4. The index whose elements got got to be negated was 3. So this was the case. So in this manner, every particular so initially all the elements are positive, as we can see. All the elements are positive, right? Now, when I'm negating some particular element, what I am saying, I am identifying that there was some element present which negated you. That means the original element was present once. I am sure of it, that it was present once. That is why you became negative. Okay, so Karthik is saying that he can't get this logic. So, see, Karthik, this 4 was there, right? This was the very first element. Earlier, my map was saying that 4 appeared once, so I didn't have to check anything again, and I could simply rule it out that it won't be a part of my answer, right? Now I need to identify that, yeah, this 4 appears. I'm simply doing that. So, yeah, this 4, how can we make it identify? So I am using one particular strategy here for the, okay, first things first, okay, the question in each of your minds would be, first things, if nums is having a size of n, then how are we able to do this particular manipulation of the indexes? The reason why we are able to have the manipulation of these indexes is, let me write it here. All the elements are in the range of 1 to n. Now, if we subtract 1 from each of them, so the range becomes 0 to n minus 1. I hope I was able to explain you that this is the reason why we are able to use the elements manipulation and use that as an index. So this was my first saying. Another thing, to continuing with Karthik's query. So I need to identify that, yeah, 4 appeared. So what I'm doing is I subtracted 1 from this 4, and the element which was present at this particular new index, the new index that came at this point was 3. I negated that. I simply multiplied that with minus 1. So the index came was 3, 4 minus 1 is 3, right? And the value was 7. So 7 got negative. 7 became minus 7. So in my next traversal, just assume that this traversal went by. Our first traversal is gone. In the second traversal, this thing, at index 3, we find out that this particular element 7 was there and 7 was negative. Now, what does that mean? Some particular element must have been present, which must have made this element as negative. Otherwise, it wouldn't have been negative. I will come to the else case as well. But first, let's solve the if case. If it is negative, then that means if it is negative, then that means it got multiplied by minus 1 once, right? So the original element must have been present. How to get the original element? We have the index. And how we got to know about this index? By subtracting 1 from the original element. Now in order to gain the original element back, we will add plus 1. So the original element becomes 4. I hope I was able to explain you, Karthik, now. Okay, so this was the crux of the solution. Now in the else part, just one thing I would like to say, because every element that appears twice, that will also be making some other elements negative, but they will be making it twice. And if an element is made negative twice, made to multiply with a negative element twice, that would become positive, that would remain positive, you can say. So what is the resultant of this particular entire my conversation? The resultant is that every element that appears twice, every element that remains positive after this approach, can come in our result, because that would be the one that would be actually coming twice, right? So now so this is the approach that we will be taking. Let's just quickly code it out. Index equals 0. Let me just give me 2 minutes. I'll just code it out. Now, so first formulate the index, which would be, I'll share with you why I'm using this absolute function, and I'll simply multiply nums of ind with -1. Now, if after multiplying this nums of ind becomes greater than 0, then that means, okay.
Yeah,
Okay,
Anubhav.
not ind.
Hi, Anubhav.
Yeah.
So basically, we'll have to end the class because already we have a paid class at 8:10. We have moved.
Yeah. Just let me just finish this code up. Just can you give a minute?
Yeah, sure.
So as I have stated, now I'll simply return my return this resultant vector. Sorry, what is the issue as of now? Okay. Push back. And IND. Numset IND was the one which could actually be coming twice. Okay, so we have some issues. Okay, we need to use the absolute again. Okay, so absolute we have seen in the wrong case as well. Elements can become negative after this first processing. That is why we need to use the absolute functionality. So in this manner, according to my logic, as we have seen, the time complexity is linear and space complexity is constant. So yeah, this was the class entirely. If you have any particular questions, do ask in the comment section and I'll be happy to reply.
Thank you, guys.
Thank you, sir.
We will meet soon. Okay, bye.
Thank you.